Yeah, this apparatus got three parts. The first part is to produce hydrogen gas. The second part is to dry the hydrogen gas. And the third part is the main reaction. The main reaction here is actually a redox reaction. So you wouldn't know whether they will combine redox and this chapter together or not. So how do they do this experiment? Let's just assume that X is actually Cu, so copper 2 oxide. The main reaction here, we are going to react CuO with H2. It is actually from the redox, the reactivity series. We know that hydrogen is higher than copper in the reactivity series. If you still can remember the reactivity series, which is here, in your Form 5 Chapter 3, the position of hydrogen is here. Copper is placed lower than hydrogen. So we can use this hydrogen to steal away the girlfriend of Cu. H2 and O, they form H2O. When the girlfriend has been stolen, it will become Cu only. So this is called a redox reaction, gaining and losing oxygen. And then, what is the purpose of doing this experiment? Why we want the hydrogen gas to steal away the girlfriend of oxygen, the girlfriend of copper? The reason is because, okay, it's like today I give you one example. I just bought a piece of copper 2 oxide, and I wanted to know in this copper 2 oxide, let's say 10 grams of copper 2 oxide. In the 10 grams of copper 2 oxide, it is made up of how many grams of Cu and how many grams of oxygen. I want to know about this, but what can I do? You can't just like remove all the copper like that. So you have to let it undergo a reaction. And the reaction here is a redox reaction. So what happened is, let's say you see 10 grams of CuO. The 10 grams of CuO, when it reacted with hydrogen, it turns into Cu. CuO to Cu, it loses oxygen. So this is actually a reduction. From CuO to Cu, the mass will decrease. Let's say it decreased to 7 grams. So from here you can see, oh, by doing this experiment, I can find out that the mass of copper is 7. And then from here, 10 grams in total, 7 grams of copper, it will consist of 3 grams of oxygen. So the purpose of this experiment is to find out the composition of the metal oxide. How many grams of the metal and how many grams of the oxygen. So you can see everything is recorded here. The mass of the Cu and the oxide. So you can minus off everything here to find the mass of oxygen. And then you can see before the experiment, copper 2 oxide is 18.27 grams. After the reaction, it becomes copper only. The mass has decreased. That's what I told you just now. The mass has decreased. 慧琪，你可以不用上了，你可以过后才跟我拿 video。你去读你的书啊，拜拜。拜拜。Okay, now let's answer the first question. Name the chemical substance W, Y, and Z used in the diagram 3. So Y, Z, and also W. Where is W? Oh, W is here. So let's solve the first part of the diagram, which is to produce hydrogen gas. So we need W and Z to react together and then produce hydrogen gas. We always know that hydrogen is come from acid. So you can see in the part 1 diagram, the liquid must be an acid. So I can say that W is always an acid. While what is the Y? You see, Y is actually a solid. This solid reacts with the acid and it will be able to produce hydrogen gas. Let's just say W is hydrochloric acid. We want the hydrogen gas. That means I'm going to extract I want to take out hydrogen. So it is the same concept as stealing the girlfriend away. So what I will do is I will use a more reactive method, let's say zinc. The zinc is going to steal away the girlfriend, and they form zinc chloride. After zinc stolen the girlfriend away, then you will get the hydrogen gas alone. So this is how to produce hydrogen gas. So 2. So from here, you have to remember, you need a solution that is an acid. It can be any acid, sorry. It can be nitric acid, hydrochloric acid, or sulfuric acid. And then Y has to be a reactive metal. It has to be a reactive metal, more reactive than hydrogen. It can be magnesium la, zinc la, calcium la. But remember, not sodium or potassium that can cause explosion. Then part 2, drying hydrogen gas. We need something to dry the hydrogen gas. What is the thing to dry hydrogen gas? Yes, very good, Ernest. Anhydrous calcium chloride. So we will be using anhydrous calcium chloride to dry the hydrogen gas. So my answer for this question is hydrochloric acid, zinc, and anhydrous calcium chloride. Of course, it can be another acid, it can be another metal. They want me to write an equation. My equation is here already. Oh. Okay, and then empirical formula. The steps to find empirical formula is MMR, mass, mole, and ratio. MMR, mass, mole, and ratio. How to find the mass? Some people might not know how to find the mass. I want to find the mass of CuO. How to find the mass of CuO? You see, I want copper. That means I don't want the mass of combustion tube. So what I will do is I have to minus off the mass of combustion tube. So I will use this number to minus 16.82. And then to find the mass of oxygen, that means the oxide here. I want to find the oxide, then I have to minus off everything. Mass of combustion tube and CuO. That means I will be using this figure, 18.27 to minus 17.98. So 18.27 minus 17.98. Yeah. And then you will get a number. That one I'm not going to do lah, okay, because everybody can do the deduction. Okay, after you deduct it, you just use the number to divide the molar mass. Then you will be able to find the mole. Okay, divide molar mass. You will be able to find the mole. And then you just find the ratio. Okay, next. The answer here, it will be 11 CuO. What is the function of Z, and then suggest another chemical to replace it? So as we mentioned, in the middle part, the substance Z is actually to dry the hydrogen gas. What is another chemical to replace it? Can anyone give me the answer? What is another drying agent that can be used to replace the anhydrous calcium chloride here? Another chemical substance that can replace the anhydrous calcium chloride. Anyone? Silica gel, no. No one know the answer? Yes, Shekai, thank you very much. The answer is concentrated sulfuric acid. Concentrated sulfuric acid. Okay, next, why is hydrogen gas passed through the combustion tube for a few minutes before heating? So what they do is they will allow the hydrogen gas to pass through the apparatus for a few minutes before they started heating the metal oxide. Why? So the reason here is to remove or to ensure all the oxygen gas in combustion tube is removed. We want to remove oxygen gas. Why? Because if you don't remove the oxygen gas, the O2 and H2 mix together and you start heating this substance, it can cause explosion. Just like when you want to test hydrogen gas, hydrogen gas with a lighted or burning wooden splinter, it can produce a pop sound, right? It can produce a pop sound. So a small pop is like a small explosion occur. You don't want this to happen in your combustion tube, which has large amount of hydrogen gas that can be very dangerous. So that's why you have to make sure all the air will be removed. And then state observation at combustion tube in the experiment. So what will be the observation? In the experiment, the copper 2 oxide, as we said, will be reduced to copper. The color change will be from, so the black copper 2 oxide is going to turn brown. Yes, just like that. Write chemical equation for the reaction between hydrogen and oxide of copper. So that's the equation that I wrote just now. CuO plus H2 is still away the girlfriend. You get Cu plus H2O. Before copper oxide is heated, hydrogen gas is allowed to pass through the apparatus until all the air is removed. How are you going to ensure all the air or oxygen gas has been removed? How can I make sure that all the air has been removed? So this is what you have to do. This is what most people, they cannot answer. So first, you're going to collect the gas release from the small hole of combustion tube into a test tube. And so first, you will need a test tube. Okay, let me draw it out here. Okay, I will need a test tube. And then I will collect the gas from this test tube, from this combustion tube into the test tube. Of course, the one without fire. What we mentioned is before heating. So we'll collect it. And then what we do next is we want to test whether there is oxygen gas or not. You want to know whether there's oxygen gas in the combustion tube or not. So this is what you are going to do. Inside here already got H2. You want to make sure that there's no O2 combined or mixed with H2. So what you will do is you will insert a burning wooden splinter into the test tube. Okay, usually the burning wooden splinter to test hydrogen gas will be placed at the mouth of the test tube, but this is the only one that you have to insert into the test tube. Why? Okay, see, so this is what they do. In the tube already got H2. You want to find out whether it is a mixture of H2 and O2 or not. You just have to insert this burning wooden splinter into the test tube. If the test tube has H2 and O2 together, then what happened? It is going to cause a pop. If the test tube only contains H2, then what happens? There will be no pop sound. Okay, insert it. If the burning wooden splinter burns quietly without pop sound, then this shows that, or this indicates that all the air has been removed. Can? So this will be the steps that you do, that you perform, and then the observation that you are going to get to make sure that there's no more oxygen gas. If the gas that you collected tested with burning wooden splinter can cause a pop sound, that means when you hit this part later, it's going to cause a bigger explosion. Boom. Okay. So this is basically the experiment for copper 2 oxide. And then other question. Wait. Okay, let's see. This other question, but similar experiment lah. One precaution that must be taken when carrying out this experiment. When they ask you precaution, what is the precaution? The precaution is actually this. Hydrogen gas must pass through. Yes, Cassandra, this is chapter 3, empirical formula, the experiment, the 2 experiment. You must allow hydrogen gas to flow through your combustion tube a few minutes before heating. This is the precaution steps. That means when they ask you for the precaution, they are asking you from the other way around. Okay, so you just have to give them this answer. You allow the hydrogen gas to flow for a few minutes before heating. And then, this question. Why is hydrogen gas passed through the combustion tube after heating has stopped? That means even if the reaction has completed, you have finished the experiment, but you will still let hydrogen gas to flow continuously until the whole metal is cooled to room temperature. Why? See, now I'm no longer heating this part anymore. No more heating. It is in the cooling process now, but I will still let H2 flow continuously. Why? This is to prevent oxygen gas, or you can say air, from entering. That means you don't want oxygen to enter the combustion tube and react with the hot metal. Of course, if the metal is copper, then we'll say hot copper. Because if it is hot, it can still react with the oxygen to form copper oxide or a metal oxide. So that is the reason. And then, can the empirical formula of magnesium oxide be determined by using the same method? We all know that the 2 experiments are carried out different way. So when they ask you, can I use magnesium ribbon in this reaction? Of course, the answer will be no. Why? Why is it no? Okay, because why? You see, this experiment number 1 is using hydrogen to steal away your girlfriend. We cannot use magnesium is because magnesium is higher than hydrogen. That means hydrogen is less reactive than magnesium. Hydrogen is not able. So they are asking you whether you can use H2 to steal away the girlfriend of Mg to form MgO and H2O. The answer is no, because hydrogen is less reactive than magnesium. So no reaction will occur. Name another metal that is suitable to be used in this experiment. So what kind of metal oxide can be used to replace the copper? Of course, it can be anything that is lower than hydrogen in the reactivity series. It can be iron, it can be tin, it can be lead, it can be copper, silver. So anything that's lower than hydrogen, usually we'll say lead, okay? Lead, silver. Finish. Last, the second experiment. So this experiment, what is the difference between this one and the one just now? Actually, the purpose of carrying out this experiment is the same. They want to find the composition. They want to find the mass of metal and oxide in the substance. Because copper is not reactive. Copper is like iron. If you use a lighter to burn iron, it is not going to react with oxygen and form iron oxide. It will just become hot. It is like you want copper to react with oxygen, you want to burn it in oxygen, nothing will happen because copper is not reactive enough to form CuO like that. So the only way we can do is, it is not reactive, we can't let it react with oxygen directly, so we can only use a more reactive substance to steal the girlfriend so that we can know the mass of different substances, copper and oxygen. But now, when it comes to magnesium ribbon, which is too reactive, which is a lot more reactive than copper, even the hydrogen also cannot steal the girlfriend. It is too handsome already. So what happens? We can let this reactive metal to react with oxygen straight away. That means what we do. I have 7 grams of magnesium, let's say. I allowed it to burn in oxygen. After the experiment, I just weigh the mass of this product form. Maybe it's 10 grams. Oh, then I know. Before experiment 7, after experiment 10, that means oxygen is 3 grams. You get it? So you see, by doing this experiment, I am able to find out the mass of the composition. Okay. Same, we will go through this experiment. What is mean by empirical formula? This definition I skip. Yes, if you want to use this method, you must make sure that the metal is more reactive than hydrogen. Calculate the mass of magnesium and the mass of oxygen that has reacted. This one I also skip, same as the one just now. If you want magnesium ribbon, you just minus off crucible and lead. Crucible and lead. And then if you want oxide, you want to minus off crucible, lead, and magnesium. That means the mass here, the second mass. Next, calculate the ratio. This I keep is like the empirical formula steps. Equation. So equation I have wrote it just now. Mg plus O2. It forms MgO. 2. Why was the crucible lid open once in a while during the experiment? Yeah, this is a popular question. Why do you have to open? If you still can remember how you carry out the experiment, you will open the lid. You will open up the lid, okay, once in a while. Why? Why do you want to open? Yes, correct. To allow oxygen gas to enter the crucible and react with magnesium. You open it to allow oxygen gas to go in, but then you also have to remember, they will also ask you the other way around, another one, which is why do you have to close it? You don't just let the lid open like that. You will close it back. After you open it, you'll close it back. Open, close. Why do you have to close? Close is to prevent the white fumes of magnesium oxide from escaping. The white fumes is actually the product, magnesium oxide. If the magnesium oxide escapes from your crucible, then what happens? It is going to affect the mass here. When it affects the mass, that means the result will become inaccurate. So you don't want this to happen. So this is why you have to close it immediately after you open. So open, close, open, close. When do we stop the experiment? What does it mean by this question? When do we stop the experiment? When you are heating this magnesium, how long do you have to heat this magnesium? When do I have to stop? Okay, when they ask you this question means they are asking you whether it has reacted completely or not. How I know whether this substance has reacted completely? Just like the copper 2 oxide just now, they can ask you back the same question. Okay, some people will say color. I observe the color change. If the magnesium turns white, then I stop. Or the black metal copper 2 oxide turns brown, then I stop. No, you can't say that because the surface might has turned into copper already, but inside the substance, there are still some part that has not yet reacted. So what you got to do is you have to repeat heating, cooling, and weighing process until a constant mass is obtained. Repeat heating, cooling, and weighing process until a constant mass is obtained. That means you cannot tell by looking at the substance. What you got to do is, after I heat it, now I cool it. I cool it down. I take the whole thing out and I weigh the mass. Let's say the mass just now is started from 7 grams of Mg. After 5 minutes of heating, it has turned to 9 grams because it has reacted with oxygen. So this is my first result. What I do, after I got the first result, I put it back and heat the second time. And then I repeat, cool, I wait again. And I see, if the mass increased to 10, that means the one just now not yet reacted completely. After the 10 gram, you will just put it back, heat, cool, and then do it again. If the result become constant after a few times of heating, cooling, and weighing, they are still the same. That means it has reacted completely already. So this is what they mean. 2 precaution steps. So the precaution steps will be the open and close. It has to be open once in a while. Okay, and then it has to be closed at interval or open as interval with the 2 reasons. And of course, you can add this in, which is clean the magnesium with sandpaper before heating. And then you know what? Precaution can also be this answer. Repeat heating, cooling, and weighing process. Same for this copper 2 oxide. That means when they ask you precaution, you can also write the same answer. Repeat heating, cooling, and weighing process until a constant mass is obtained. Just like that. So the experiment is very similar with the same purpose, but 2 different ways. One is stealing girlfriend, another is react directly. So why the empirical formula of copper 2 oxide cannot be determined by using this method? Because you have to know, copper is not reactive. So copper is not a reactive metal. Copper is not a reactive metal. That means it cannot react with oxygen directly. It can't burn in oxygen. Suggest a method to remove a magnesium oxide layer before heating. That's what we mentioned earlier. You can clean it with sandpaper. Last, name of another metal oxide whose empirical formula can be determined by using this technique. So this technique is for reactive metal. Reactive metal can burn directly. So what are the metals? Those metals that are placed higher than hydrogen. It can be zinc, it can be aluminium, magnesium, calcium, but never mention calcium and sodium, okay, because they are too reactive. State the change that occurs when magnesium starts burning. Magnesium, what is the color of magnesium? Magnesium. What is the color of magnesium? When it turns to MgO, MgO, MgO is white color. What is the color of Mg? What is the color of magnesium? A gray. So the gray, okay, or you can say shiny gray, silvery gray, okay, or gray solid turns white. Just like that. Okay, can. Next week, we will be doing, starting from next week, we will start to do exam question. We will no longer go through chapter by chapter anymore. We will straight away start to do chapter-based exam question. And then, yeah, if it is better if you can prepare before you come to the class. Next week, we'll be doing periodic table exam question. Okay, last time, the time we go through is we going through the notes, but we never do the exercise yet. So next week, we'll be doing chapter 4. And then we'll do chapter 5, and then we'll do chapter 9. Okay, can. So that's all for this class. If you have any question, you can ask me. Next week, it will be a new note. Next week, we are using new notes. Sitting better, don't write silver. Next week, you come to the class and you will get the notes. Bye-bye.